Now, tying it all together from this section, we're going to look at trying to have a complete graph of a polynomial, maybe using our TI. But before we do that, we want to utilize the theory of this section to help us predict as many behaviors of this function as possible. So the first thing I would do before even pulling my TI out would be to identify the degree. That's going to give us a lot of ideas. So for f of x equals negative x to the fourth minus 4x cubed plus 25x squared plus 75x plus 20, we're noticing that it's already in descending order. So I'm going to look at my leading term, which is negative x to the fourth. And from my leading term, I will get the ideas of the degree. And we notice the highest power of the x, the degree will be 4. So that could right away help me out with n behavior. 4 is an even number. So we have a choice with the n behavior, could be it could either be up, up, or down, down, both pointing the same direction with even degree. But because I have a negative leading coefficient, I do know that the endpoint behavior will in fact be both ends pointing down. So we can describe that as down, down. So we'll know what to look for in that sense. The other thing I'll toy around with is again using the degree to determine my maximum number of roots. So again, the degree is 4. So that tells me that the maximum number of roots, or sometimes zeros or X-intercepts, will be in fact the same as the degree. So we notice if we already see 4 roots in our viewing window, we don't have to widen it out with X-min or X-max anymore. But please keep in mind that you're not always going to see the 4 roots. It could be 4 roots, 3 roots, 2 roots, 1 root, or 0 roots. But the max you'll ever see is 4 depending on the degree. The other thing with the degree, it will help us out with our local extrema. If we're going to determine how many local extremas we have, maxes or mins we'll see, it always has to do with the degree minus 1. So degree minus 1, that's 4 minus 1 equals 3. So there should either be 3 local extrema that we'll be looking for. So that would be noticing maxes or mins. Or it could be less than that by an even multiple of 2. So if I subtract off 2 from 3, 3 minus 2, that's equal to 1. So we have 2 possibilities, 3 or 1 local extrema. So we don't really know yet whether they're going to be maxes or mins, but at least we know there's at least 1 that we can look for in our window. And we could also talk about inflection points, but at this point, I'm going to leave it up to you to kind of determine this. The problems won't ask you to find them in this sense, so I won't address it here. We could just subtract off 2 and determine that we have at most 2 inflection points or 0 inflection points, but at this point, let's not address it. So now that I have an idea of what my function is going to behave like, what I'd like to do is pull out my TI and type it in. So we're going to switch over just a little bit. And I'm going to press Y equals the function editor to pull up my screen. And then I'll type in our function. So I should have, remember when you're using a negative, if it's the leading coefficient, you have to use the negative key. If you use the minus key, the calculator gives you an error. So that could be kind of a problem-solving issue there too. We'll figure that out. So we have negative x to the fourth minus 4x cubed plus 25x squared plus 75x plus 20. And I always double check because I'm typing in so many terms. I'm always going to look back at my original problem and double check that I have all of the terms correct, not missing any signs, or didn't actually accidentally press an extra variable or anything like that. So always double check. Take care doing this now, and then you don't have any issues later. So I'm just double checking as we see, and we have it. So I'll press enter. So that's entered into the calculator. I don't remember what my previous viewing window was, but I'll press graph and I'll just interpret it that way. So then, okay, I think I had the standard viewing window. And what you're kind of noticing is you don't really see mins or maxes, but if you want to play with this, we actually see that there's 4 X-intercepts. So this is really good news because this tells us that's the maximum amount of X-intercepts we could have is the degree, which is 4. So this gives me a hint that I'm not going to have to deal with widening out my X min and my X max. So I don't have to worry about left and right. I already have that taken care of. What I do want to have is actually I would like to raise my Y mins and Y maxes, or widen them out, I should say, so that I could kind of get a view of the complete graph. So there's more than one way to do this. Sometimes I just make a guess and then go with it. Some people prefer to use the zoom fit. We'll try that and then we'll have a discussion. Sometimes it helps, but then again, sometimes we still end up having to reduce and revise our window. So zoom fit, I have to actually scroll. I press zoom, I scroll down, and that's item number 0. So you kind of see when I press it, it gives me an idea. It looks like I see a little bit of max right at the top and a little bit of, maybe there's a min somewhere in there, but it's not the best representation of my graph. However, it did narrow down my width a lot. So let's go look at our window. Remember, we don't have to widen it out or anything. It's the up and down part that we have to deal with. So again, if I'm looking at my Y min, wow, it's negative 10,730. And my Y max being 281 about, I might notice, let me go back and show you one more time, that it looks like we're a little bit too open in the lower part of the graph, and maybe we want to interpret our upper part of the graph a little more. So one thing you could do, and it's all an experiment, it's nothing that we know that we have a great, there's no like one way to do it. I might try to maybe match my Y min and Y max, see if that helps at all. So it looks like Y max is a little lower, so maybe I'll pull it up to 10,000. You know, this may be overestimating, but again, like I said, we might be able to get a more centered view and understand what's happening with our graph. And then I kind of notice it still looks a little flat. I still kind of see that it looks like there's some sort of local mins or local maxes happening, but I'm not quite seeing it so that I can calculate it. So this might be a case, then we go back and revise, and let's cut it down a little bit. So let's maybe make our, I mean, we were really exaggerating with the 10,000. So let me cut them in half. Let's see what happens. Maybe I could do 5,000 in both. And they don't always have to be symmetric. You could always play around. But I'm starting to notice, okay, I started to see a local max a little on the right side of the graph. There's possibly one on the left side, and there looks like there might be some sort of min happening. But I do want to inspect this a little more to be sure. I don't want to just calculate as general. So maybe it might be useful. Maybe I'll play around. Maybe my window is a little too high. Maybe I'll change my Y max. Maybe I'll just make it, I'll make a guess. I'll just do 1,000, see what happens. And then I'm feeling a little better now. I'm starting to see a clear idea of my local extrema. So see what I did. So just remember, the first window we pick is not always the best one. And if it happens to be that it gives you the comprehensive graph, then great. But I just want you to get into the habit of just experimenting and being patient. We're trying to see your function a little bit better. We could expand this a little bit if we need to, but I do kind of see a clear enough view. I'll take a little more time with you. Might as well, right? So maybe we'll take maybe our y min. Let's make it maybe like -2000. Sometimes this helps with not having everything so wide, and you start to see a little bit more of the format of your graph. So depending on what you take, you could have a graph that looks a little bit different. Maybe your local maxima and minima, or maybe a little more steeper. Depends on your y mins and your y max. But this is a pretty good idea of what your function would look like. So I'll leave it at that. What I'd like to do now, usually when we are trying to prove our work on paper, I will take this graph and I'll sketch it. Right now, I'll copy it over. That's kind of the nice benefits of technology here. So I'll just copy it over to our particular work, just so that I can refer back to it later. Now, if you don't have that technology, because usually we don't when we're taking an exam, what you can do is just draw a quick sketch, and that's okay. Let's see if we can paste it. And I do have it, but it just didn't show up in the right place. So I'll see if I can move it onto my picture a little bit. Sometimes things don't agree. So let's try. I'll just move it over to the right side of the graph. I made it a little too small, but I'll go with it. Oh, I guess I can't move it up, but don't worry. I will refer back to it in a second. I'll just make it larger so I can point out some important parts. And that's what happens. We try to play with technology. Sometimes it doesn't quite work out, but might have been just easier to sketch the graph, and that's fine too. So I'll just leave it centered here below. But I would like to point out at least that I can refer to it. Now that I have a comprehensive graph, I'm showing the end behavior, I'm showing all of my local extrema and all of the roots, I can start by finding what they're asking me to find. So the first thing I'm going to look for is the X-intercepts. And if I'm looking at my graph, I can see them. I can kind of point them out. However, they don't look like they land on nice numbers. And this is the reason why we want to use our TI to help us. So we do have our X-intercepts that we're going to label. And what I'd like to do is go back to the TI and actually find the accurate calculation of them. So we'll do that. And depending on your version, your operating system of your TI, there's more than one way to do this. I will take it so I cover everyone. There may be a faster way to do it depending on this, but feel free to read the textbook so that you can get that if you are interested. So if I'm going to calculate the intercepts, I'm going to do second calculate, and it's going to be the zeros. A lot of different ways to refer to the X-intercepts, huh? So I'm going to go, I just like to go in order so I don't get confused. So I'm going to go with the furthest or farthest intercept on the left. I'm going to pick my left bound, press enter, move a little bit up to pick my right bound of that X-intercept, and I will calculate it. So I do have -6.1671 maybe. And I don't believe it's asking me to round, but if it did, I'd have to follow those directions. So what I'd probably do is I'll round to the nearest hundredth or 2 decimal places when they don't ask. It's useful. So I have -6.17. So I'm going to write that down so I can get back to that later. I'm going to also just repeat the process a little bit more, 3 more times. So we're just going to move and find our left bound. Looks like we're hovering around here. A little bit more, find our right bound, so a little bit to the right. The next X-intercept are 0. Looks like we have negative 2.29. So I'll write that down. Second, calculate. It's our favorite button, right? Calculate that 0 one more time, or 2 more times. We have a left bound. A little bit, I think I'm a little bit short, so I'm gonna, I think there's one happening over here. Now, if we need to zoom in a little, we can. If you end up having not a good vision of your complete graph, it's okay. But it looks like I can take care of my intercept on this one. That one's a little questionable though. It is very small, huh? So if I were looking at this one, I'd probably round negative 0.30, 2 decimal places, or negative 0.3 could also work. One more time. Second, trace. We're going to calculate that last X-intercept. It's way over here. So we're going to move over. Pretty good. We got our right bound. Excuse me, left bound. Press enter. Now we get our right bound. It's a little ahead of myself. Press enter, and we have it. So we should have about 4.76. So before I forget, I will go back and I'll address the answers to the directions. And it looks like my X-intercepts, because I found them in order, I can list them. Negative 6.17, negative 2.29, negative 0.3, and 4.76. So that's one way to list the X-intercepts. If you would like, you could have also written them, excuse me, in ordered pair form. So you might see it where you have zeros, so the Y value is 0. Sometimes at this point when we're dealing with polynomials, we don't take time to write this because we already know that when we're finding the zeros or the X-intercept, it's already implied that the Y value is 0. But feel free, either way would work. So let's double check. I feel accomplished, but I don't know if I answered everything. So I'm gonna go back and read my directions. I got my X-intercepts, check. Next thing it wants me to find is the Y-intercept. So let's do that. There's more than one way to go. Actually, a Y-intercept is nice if you want to inspect the function. You could just take it straight with f of x. Y-intercepts happen when x equals 0. So if you were to plug in 0 to your function, and you really don't have to manually do this, you can actually start to see what will happen is all the terms that have x in it end up zeroing out and, in a sense, disappearing. So you end up getting, when x equals 0, y equals 20. There's a Y-intercept there. So that's one way to do it. We don't always have to write out the steps to that. So I can address that down here as well. So my Y-intercept, there's only one. So that would be 20. You just want to label that. Or if you prefer to write it in ordered pair, remember it's when x is 0, y is 20. And that we can kind of tell it's over here. Now, if you're kind of already have your TI screen up, another way to do this, just in case, let me share this with you. We'll go back and it's kind of doing the same thing, but it lets your TI do the calculations. You could technically find the Y-intercept if you just press trace, not second, but just trace. And you can tell it what X value you want. So if we want the Y-intercept, we want X to be 0. And if you press enter, it will automatically go to your Y-intercept. So that's kind of a cool thing too. So if you didn't know that already, then you just learned something new. But again, we can use our function. We don't need the TI to do this. Okay, so let's move on. So let's go back, make sure. Looks like we found the Y-intercept. I'm gonna go check my directions one more time. We're good to go on the Y-intercept. The last thing is local extrema. Okay, so let's take a look at the local extrema. If I'm going to look at my graph, I can tell for sure. I do have a local extrema, looks like a local max. I have two local max, or maxima. So according to what our findings are based off of the degree, we're only supposed to have either 3 local extrema or 1 local extrema. So it looks like because we found 2 right away that are a little more obvious to us, it must mean that we should have another local extrema somewhere. It looks like a local min happening. So that kind of gives us a clue of what we're looking for. Sometimes that when your graph is not stretched out enough, it may appear that you have a local min, but it's really an inflection point. So I just want to point out that the degree gives us that information to proceed with finding that local min for sure. So we're going to go with our calculator. So I'm going to say I have my local max. I'm going to give you ordered pairs for these. And we'll probably have to deal with the local min. So let's use our TI because I don't think we can't really find them without that. So we're going to switch back. It's a little easier when you have your handheld calculator than on the screen, but we'll go with this. So again, I'll do this all in order. I'm going to press second trace to get that calculation. And if I'm looking at the far left of the graph, it looks like I want to look at the maximum. So I'm going to move over. You could start off wherever you like, but I like going from left to right because then it ensures I don't forget anyone. So local max would be right here. Left bound maybe, right bound will move over a little bit. I like to exaggerate when they look a little flat. So then I'll make a guess. And I do have a maximum at negative 4.7. I'm going to round to the nearest hundredth, so 2 decimal places. Don't forget also that we want to take the y value. That's usually important to us because the y value is the input or the output of after you're figuring this out. So about 147.53. So I'll write that down and address that in a second. But while I have my TI screen up, let's do another calculation. I'm going for the one in the middle. I'm going to do a minimum. So I'm going to move over a little left bound. Looks like we're maybe around here. And a little right bound. Move over. So now it looks like we have a local minimum. And remember, if you're not identifying whether it's a max or min, it could get really confused. So make sure you understand that first and you indicate this. So it looks like it's negative 1.28 if we're rounding, and the y value negative 29.34 or so. So I'll write that down. I'll get back to that. And one more to go. Second, calculate. This time we were looking for a maximum. So that's item number 4. So we'll move our cursor over just a little bit more. Left bound, we'll select an X value, move over again, and the right bound, I'll exaggerate a little bit just so I see this. And we'll let our calculator guess. And we do have another maximum or local maximum at about 3.07, and maybe y is 281.31 or so. So that's nice. We actually got the correct values, really accurate from here. I'm just going to go back and address this in my problem so that we're entering this in. And generally, if you have a graph, you could label them just so that you kind of see. We do have a local min here, and we do have some local maxes here. Or should I should be a little more proper with my English, is local maxima. A little fancier there. So now if we just want to put this in the right place, depending if the directions want all of them, I'm going to make sure I'm labeling them in the correct ideas of being local mins or local maxes. So local max, I have 2 of them. Writing them as an ordered pair, I have negative 4.79, 147.53. That's one of them. The other one we just found, 3.07. And about 281.31. And then we only had one local min that happened to be negative 1.28 and negative 29.34. So just make sure you're writing the correct ordered pairs in the right place. Don't switch around your maxes and mins, that could get confusing. So I think we are done. Let's just double check one more time. That's my rule of thumb whenever we're doing long problems. Make sure you answered everything the directions said. We found all the local extrema. For the local extrema, we wrote the ordered pair, check. Looks like we are good to go. So we have our final answers all summarized right around here. I hope this helps. We'll see you next section.